In this problem, you are asked which method makes the most sense for this problem solved below, and then use your method to solve it. So I know to solve that I have a system of equations here, right? Because I have two or more equations with the same variables. They both have x and y. And if it's asking me to solve this, I know that I have two methods so far. I know that I've got the graphing method. Remember that the graphing method literally means to graph the two lines in y equals mx plus b form and find the point where they intersect, and that's the solution. The other method that we learned is substitution. Now, substitution method is the best when you can substitute one equation into the other. Now, when I glance at these equations, I know that the graphing method is best when they're in slope-intercept form, and it would be really easy to graph them. When I look over here, this is not in slope-intercept form. This is not in slope-intercept form. So I would have to rearrange them, and then I would have to graph them, which feels like a lot of work. So let's take a look at substitution method. I know that it's a clue to use substitution method when one of my equations has at least one variable isolated by itself so that I can substitute it into the other equation. So right off the bat, I can see, oh yeah, the easiest method for this one is substitution. So now let's do it. So I'm going to take my first equation and I'm going to rewrite it. 4x plus 3y equals 7. And now the cool thing is I know that x is equal to 2y minus 1. They are worth the exact same amount. They are equal to each other. That means that in place of this x right here, I can substitute in this value because they are equal to each other. They are the same value or the same amount. So let's do it. So I have 4. And now I'm going to put parentheses because, as you know by now, we always use parentheses when we substitute things in or out of an equation. Now I'm just going to copy the rest of it. Plus 3y equals 7. Now you should notice it's literally the exact same equation, but I substituted in for x using the other equation. And now why this is useful is now I only have y variables in this equation, and I can just solve it. You're experts at solving equations at this point. So let's do it. I've got some distributive property here. So let's see, I get 8y minus 4, watching the signs, plus 3y equals 7. If you haven't already done this on your own, it's always good to just pause the video and do it yourself, and then watch me go through to check. That's really how you're going to learn. Just watching me do things isn't going to help you learn. So either do it yourself first or follow along in your notebook. Okay, we have like terms over here. So I can see that I have 11y minus 4 equals 7. I kind of have my line a little funny, but plus 4. Look at this. I'm left with 11y equals 11. Divide both sides by 11, and I have y equals 1. So there's my first part of my answer. And now it's always easy when I have 1 because I can just plug it back in. You can pick either original equation again and just plug in the one answer you have and solve for the other. So again, I'm going to use that second equation because it's just a little more straightforward. X equals 2 times 1 minus 1. X equals 2 minus 1. Oh, look, I have x equals 1 also. So I know the solution to a system is the coordinate where they intersect. So I'm going to make sure that I write my answer as a coordinate with parentheses, a comma, all that kind of good stuff. So again, the question asked, which method makes the most sense to use for this problem? Well, it's definitely substitution. And the reason is because we had one variable isolated by itself. So it made it really easy to substitute into the other equation. And then we solved it using the substitution method, just like the problem asked. And that's that.